Good afternoon. If you're just joining us, we will get started here with our webinar in about 5 minutes. We'll get started in about 5 minutes. Thank you so much for being here. Good morning, students and teachers. I guess I should say good afternoon, students and teachers. Welcome to the live stream. We're going to get started here in about 2 minutes, just another 2 minutes. So please hang tight and we'll get started in just 2 minutes. Thank you so much. Okay, Great. Welcome everyone to our second week of Discovery Festival. I am so happy you're here. We're also happy that you're here. This, of course, being our virtual Discovery Festival. I'm going to first, just real quick, I'm going to mention who I am and then what this festival is. So my name is Will Tapia. I am the Advancement Coordinator for Big Brothers Big Sisters of Central New Mexico. And normally, outside of a pandemic, I'm responsible for putting this one-day event on Discovery Festival. It's usually one day. It happens at the Albuquerque Convention Center. We get about 3,000 students who all descend on the Albuquerque Convention Center with 50 plus exhibitors from various areas of STEAM. Now, STEAM, of course, means science, technology, engineering, art, and mathematics. And these fantastic hands-on exhibits happen all day, and it's a blast. The kids get a lot out of it. The exhibitors get a lot out of it, and it is a ton of fun. However, this year, as we all know and are all keenly aware of, we find ourselves very unfortunately inside of the COVID-19 coronavirus pandemic. So unfortunately, because of this pandemic, we have not been able to have this event in person, but that won't stop us. A lot of our teachers and a lot of our students love this event. We wanted to make it available and accessible to everyone. So we decided this year to pivot our event into a totally virtual space and do a series of webinars for just about the entire month of November with various exhibitors from around the STEAM field. So that, of course, today being Friday the 13th, is the end of week 2 of Discovery Festival. I can't believe it's already been 2 weeks. But don't worry. If you visit our website, discoveryfestnm.org, and we'll be sure to post that in the YouTube chat. If you visit that website, you can view our exhibits, and you can view the videos of past exhibitors. So we recorded all the live streams that we did. You can go to that website and view the recorded live streams. And then, of course, as you are today, you're clicking on the live streams. You can see when live streams are scheduled for the next week and a half. So we're very excited about this. And today at 3 o'clock, you have about an hour to submit if you haven't yet. 3 o'clock today will be the deadline for the virtual STEM Fair and Art Expo. We're really excited about that. This, of course, is something I know a lot of students, your science fairs have been canceled around the state or postponed and things like that. And so we made this event, the virtual STEAM Fair and Art Expo, so you can record yourself doing a science project or create an art project based off of an area of STEAM that you like. Submit it for prizes. Every single student who submits for either one of those competitions, every single one of those students who submits a project is entered into a raffle to win the brand new Xbox Series S. I am excited. I wish I could win that. Okay, so that's going to close today at 3 p.m. So don't forget about that, students. It should be pretty awesome. I want to real quick lay out some ground rules for this YouTube live stream and for the live stream that you're viewing it on. So if anything happens, I don't think it will. If anything crazy happens, if the live stream goes down, it hasn't happened yet, but fingers crossed, it's not going to happen. But if anything happens, it's technology. We all know how technology can be. So if the live stream goes down, go right back to our YouTube page. That's the BBBS CNM YouTube page, the one that you see here somewhere on this side. Go back to that YouTube page and you'll be able to access the live stream. We'll have it back up and running shortly. So don't worry if the stream goes down. Secondly, I see the chat is already being used. Awesome. That's super great to see. Please, if you have any questions at all at any point during this live stream, post it in the chat. Okay, and that's a live chat, so I'll be able to see it and our presenters will be able to see it. I'm going to pop on at the end and ask all those questions to our presenters for today, which is super great. So let's take a look at the chat. Speaking of which, it looks like we have some folks watching from, let's see, Ramirez Thomas, 4th grade in Santa Fe is watching. So thanks so much for watching all the way up in Santa Fe. That's awesome. This is cool, by the way, because now that we're virtual, Santa Fe wouldn't normally be able to drive to our festival because you guys are an hour away. But it's awesome that you can watch this stream and now you can participate. This is so great. Welcome to the stream, Santa Fe, New Mexico. We are so happy that you're here. And we also have Nadine Cunningham, 4th grade in New Mexico as well. So thank you. Thanks to those classes for being here. Please keep using the chat. Ask questions as they come up. There's no bad questions, and we will jump into that. Okay. Now, I keep forgetting all my stuff. I have like 15 screens open, I think, as we all do right now. So I want to do one quick thing if I can get my screen up here. I do want to give a shout out. We have some fantastic sponsors who are supporting us through this COVID-19 pandemic and this Discovery Festival. The big one, the best one, the awesome, our awesome community partners, Honeywell. They're our Da Vinci sponsor, our presenting sponsor for this entire event. Honeywell has been a community partner of Big Brothers Big Sisters for many, many, many years. And truly, this event would not happen without their support. I cannot say enough good things about this company. They're so fantastic. And of course, that's why you are all watching, is because Honeywell is on the stream today. We are so excited to bring them on here in just a couple of minutes. So sit tight. But again, Honeywell, you're truly the best. Thank you so much for your sponsorship and your partnership. To our Curie sponsor, Fidelity Investments. We had Fidelity on this week. They were absolutely awesome. Please check out their videos on our page if you haven't already. But Fidelity, thank you so much for your partnership over these years. They're another big hit at Discovery Festival every year, so thank you. To our ride sponsors, Aztec Machine and Repair out in beautiful Bloomfield, New Mexico. Thank you, Aztec. They make the awesome awards every single year for our Discovery Festival, and they're going to be doing some fun awards for us this year as well. To Air Force Research Laboratories, AFRL. These folks are coming on next week, the 17th. It should be a blast. They're going to be talking about satellites. So we are really excited about that. I know they're excited about it, and I hope you are too. So be sure to check that out. Thank you, Aztec and AFRL. To our Newton sponsors, the Defense Threat Reduction Agency, or as we like to call them, DTRA, to Micronet Solutions, Sandia National Laboratories, and Presbyterian Hospitals. Thank you all so much for coming on. DTRA, the Defense Threat Reduction Agency, is actually coming on the stream beginning next week, so be sure to check that out as well. Okay, so I'll pull that off. Okay, great. Without further ado, I think I've talked for long enough. I'm going to go ahead and introduce our two presenters from Honeywell. We have two mechanical engineers. So I'm going to have you two jump on and introduce yourselves. Do we have you both there?
Hi.
Awesome. All right, take it away.
All right, so my name is Julio Alvarado. I'm a mechanical engineer at Honeywell FMNT. Currently, I'm doing prototyping, design, and small batch production for our testers. My previous experience was working one at Cirrus Logic, doing audio processors, codecs, that kind of stuff, designing the physical portions of the codecs and whatnot. And then the other part was before that I worked at AFRL, funny enough. So I work with those satellite guys, and they're a lot of fun too.
Hey guys, and I'll go next and introduce myself. My name is James, and I am a mechanical engineer with Honeywell. And I'm from New Mexico. I went to elementary school at Bosque Farms Elementary. I went to middle school at Valencia High School. I went to middle school at Valencia Middle School and to high school at Valencia High School. And I went to college at New Mexico Tech. And now I'm working as a mechanical engineer at Honeywell, as a part designer, doing manufacturing sorts of things. So we're so glad we could join you guys today. We'll show you a cool video and we'll answer any questions that you may have for us.
Awesome. Thank you both so much. I'm glad James mentioned that. Please use that chat. Again, I see some comments coming in now. If you have any questions, anything, if you want to know how you can work at Honeywell, what should I study out of high school to work at somewhere like Honeywell? Those are all great questions. Please keep them coming. I want to give another shout out. Apparently, we have 2 4th grade classes from Ramirez Thomas Elementary out in Santa Fe. So thanks so much for being here. We are so appreciative. And we're getting some other great comments come in. Keep using that live stream chat. That's how we're going to see what you want to see and what you want to hear. Otherwise, gentlemen, thanks so much. We're going to go ahead and jump into these videos if that's okay. Sound good? Awesome. All righty. So here comes the video from Honeywell. I think you guys will enjoy. Let me make sure that this is up. Give me one moment here. Sorry about that, folks. Here we go. Perfect.
The Kansas City National Security Campus, New Mexico Operations, is an applied science and engineering organization supporting mission-critical assignments and providing technical support for national laboratories and other government agencies. With 5 locations and more than 220 employees, life cycle, logistics support, and maintenance is performed, as well as research, analysis, testing, field operations, and production. Specialized engineers provide quality assurance, circuit board design, electronic component development, machining, in-process monitoring, software development and data acquisition, fiber optic sensor development and equipment. New Mexico Operations is upgrading and providing full-spectrum maintenance for secure trailers, communication systems, and lifecycle support of mission-critical hardware and software, highlighted by complete service at one facility. Our successful history and expertise with secure tractor trailers and escort vehicles is leading the way for future design builds. As a trusted technical leader, New Mexico Operations functions in the areas of radiological search, render safe, and forensics, and responding to and resolving nuclear and radiological threats worldwide. We provide dedicated mission support for life cycle, logistics, and maintenance. We support customers at numerous sites throughout the nuclear security enterprise by providing electrical and mechanical engineering expertise for weapons programs and special partnership projects. Rapid prototype manufacturing capabilities augments these broad engineering services. With a close proximity to Sandia National Laboratories and Los Alamos National Laboratory, it sets the stage for a strong working relationship. Our engaged employees focus on customers, excel in operations, and prepare for future missions. Uniquely qualified to support the growing needs of our customers, we continue to look to the future with the goal of providing better performance, service, and products. We are proud to provide manufacturing and engineering solutions that are responsive, collaborative, and innovative. It's the people at New Mexico Operations that make the difference. Trusted technical value, strong customer relationships, and proudly supporting important national missions. New Mexico Operations, helping customers for mission readiness.
My name is Julio Alvarado, and I'm a senior mechanical engineer at Honeywell FMNT.
And I'm James Nolan, also a mechanical engineer at Honeywell FMNT.
Today, we're going to be talking about magnets and their many uses in science, engineering, and our everyday lives. What are magnets, you ask?
Great question. A naturally occurring magnet is a piece of iron that exhibits magnetic properties, allowing it to attract or repel other magnets and attract ferrous metals. A ferrous metal is a metal containing iron.
As we see here, if we orient the magnet in one direction, it attracts the other magnet. But if we change that orientation, it repels it.
And if we use the magnet on a ferrous metal, like these paper clips, we can pick them up. These naturally occurring magnets are always magnetic, meaning that the magnetic field is always on.
That's pretty cool, James. But what if we wanted to turn them off?
Well, thanks for asking. We can't turn these magnets off, but we can create a magnet using a few simple parts and some electricity to make an electromagnet.
An electromagnet is a magnet controlled by electricity. By creating an electromagnet, we can control the strength of the magnetism and when it is on or off. This means we can use it as a switch or a valve. And one of our most common valves is a solenoid.
Yes, when electricity flows through a wire, it creates a magnetic field that surrounds the wire. If we run electricity in a single piece of wire like this one, the magnetic field is very weak and not very useful.
But if we make loops around an object, like say a pencil, a nail, or a bolt, we can make a stronger electromagnet.
Yes, a long coil of wire made from many loops is called a solenoid. And when electricity is passed through the solenoid, it creates a strong magnetic field that is concentrated at its center. To create a solenoid, we will create a simple circuit. A circuit is a closed loop that electricity can flow through. And by switching the electricity on or off, we can turn the magnet on or off.
To make the solenoid, we'll need some electricity. This 12-volt battery pack will work well. Some coil wire, a switch, and some cables to connect it all together.
Now this solenoid is made from a coil that is about 320 feet long, and the wire has been looped around the spool 1,000 times. Okay. Additionally, we will need to have some sandpaper. Now let's put it together.
James, before we start, we have to make sure that we're being safe. Let's put on our personal protective equipment to ensure that we don't hurt ourselves or others. Let's wear our gloves and our goggles.
Thanks. We always want to make sure that we're safe. Now let's find out how we can make the solenoid. Let's start off by connecting the coil of wire. This is just one long wire, and it has two ends that we want to connect. One end is right here, and the other end is right here. Because this is magnet wire, it has a protective coating on the outside that we want to sand off with the sandpaper to make sure we can make a good connection. So here I can sand one end against the sandpaper. And I can tear off a piece of sandpaper here to sand the other end, right here. Now that we've taken the protective coating off of the wire, we can connect the two ends. First of all, let's take one of our alligator connection clips and connect it to this end. Next, let's take this and connect it to the positive terminal of the battery, the one with the red wire. Now, let's take another one of our cables and connect it to the other end of the solenoid. And let's connect that end to one terminal of the switch. Finally, let's take our last cable and connect it from the other terminal of the switch to the negative terminal of the battery, which is the one with the black wire. Great, now we have our solenoid assembled. If we flip the switch and turn on the electricity, we can make this coil become an electromagnet.
Okay, now that the electromagnet is made, let's go ahead and turn it on. How many paper clips do you think we can pick up?
I don't know, but there is a way to find out. We could conduct an experiment using the scientific method. Question, hypothesis, experiment, results.
Okay, the question is, how many paper clips can we pick up with the solenoid? My hypothesis, or the idea of what will happen, is that we will pick up at least one paper clip with the solenoid.
Great. Now let's conduct the experiment. As we can see, the electromagnet picked up all the paper clips. This is our result. We can now make further experiments to see different results. Like, how many paper clips would we pick up with only one loop?
Or how many we could pick up with 1,000 loops.
After this presentation, maybe you could use the scientific method and conduct your own experiments to see how many paper clips you could pick up with 1 or 100 loops.
This is great, James, but what do we use electromagnets for in our everyday lives?
Electromagnets are used for so many things in the real world. They're used in cars, in refrigerators, in farming, making robots. There are even medical applications of electromagnets.
Are they used in speakers?
Yes, they are. A speaker is actually a kind of electromagnet that uses electricity to create sound.
So you mean they're in our headphones?
Yes, they are.
That's great. I love electromagnets. James, this has been fantastic. Class, thank you for listening, and we can't wait to answer any questions you have. Oh, do our dance?
Okay, one moment here to get out of the screen. Awesome. That was great. And I see we have some questions coming in. So Julio, James, are you both still there?
Yes, we're still here.
Awesome. Okay, great. That was awesome. What a cool video. And we did get some great questions coming in from some of our students. So first up, it looks like so Allison would like to know what does electromagnetic mean?
So the word electromagnet means that when we run electricity through a wire, it creates a magnet. And so the electricity makes the magnet in a way of speaking.
Interesting. Okay. So you can turn the magnet on and off, if I'm understanding that correctly.
That's correct. Yeah. So with a regular magnet, a natural magnet, usually it's typically some sort of iron ore material. So iron's a naturally occurring element that happens on Earth and actually in the universe, really. But that iron attracts other ferrous metals, or that magnetic property attracts other ferrous metals, which has other ferrous just means it has iron in it also. So well, if we want to utilize magnetic fields, so if we want to utilize a magnet to do work, the easiest way to do that was to figure out how do we create stronger, more compact magnets, and eventually we came to understand and invent what an electromagnet is, which is what James said, which is something that we run electricity through a coil. It turns, essentially, it creates a magnetic field because of that coil, and then we can control it. We can control how big it is, how strong it is, how compact it is, and we can turn it on and off, which was a thing you couldn't do with a regular, naturally occurring magnet.
Okay, awesome. And just a couple of quick shout outs. We have a Sierra Vista, New Mexico, their 4th grade class who is watching live. So thanks so much for being here. And also we have another class from Ramirez Thomas class up in Santa Fe who are watching as well. So thanks to everyone for tuning in. Keep those questions and those comments coming. Christopher H. would like to know, where do you get a lot of your magnets?
So if it's where do we get the natural magnets?
Yeah.
Those are found in the earth, essentially. Those are found on Earth. And then when we mine, we usually will pick up magnets from mining. As for the ones we create, we kind of make them based on need and use. But if you're just talking about like the ones that go on the fridge, those have all been mined.
Mm-hmm. And you can get magnets from most stores. So you can go to Walmart and get magnets. You can go to Amazon and buy magnets. They're pretty easy to find.
So the magnets that are naturally occurring, you're telling me you guys dig down, find like a chunk of iron, right? It's magnetic.
Yeah, that's pretty much right. Sometimes, I think maybe even in New Mexico, you can find rocks that are slightly magnetic. Sometimes they're kind of hard to find, but they do exist in nature.
That's really interesting. I actually didn't know that at all. I'm learning new things. This is great. Another question is asking if there are more loops, on the magnet, the electromagnet that you were creating, will it attract and hold more paper clips?
Yes, it will. And having more loops is helpful as long as you have enough electricity to run through all of the loops that you have.
Interesting. Okay. And can you repeat the definition of a solenoid?
So a solenoid it's a wire that is looped around many times, and it forms a coil, what's called a coil of wire. It's all wrapped around a central spool you could think of.
Okay, so the whole apparatus itself is the solenoid.
Yes, that's right.
Okay, awesome. Sebastian would like to know, how hard is your work? It's It's a great question, huh?
It's an excellent question, Sebastian. Personally, I think my work's a lot of fun. It is a little difficult. Challenging is probably the better word for it.
Yeah.
But it's a lot of fun to do. We typically have worked with some of the electromagnets and some of the solenoids that we talked about today, and making sure that they're in the right enclosure and being used correctly. But our app, what we design for is so varied, and it's always changing every day, that it's a lot of fun. It's never boring. So it's challenging, not necessarily hard. I would say definitely keeps you active and keeps you motivated to keep learning and keep doing cool stuff.
Kind of like a puzzle, right? It's this mind game that you're, or not mind game, but you know what I mean? This intense puzzle that you're trying to figure out. Do you both work in a lab there at Honeywell?
Kind of, not exactly. I think we spend part of our time in the office. So we spend quite a lot of time behind a computer, doing emails, designing things and computer programs. But we also get to go to lab spaces and build the things that we design. And so you can go a lot of different places in one day, which is fun.
Well, and if any of the students want to do what you guys do, how would they go about doing that? What should they look to studying in college that you think would be a good thing?
So for I went to the University of New Mexico, so here in Albuquerque, and for me, and I think James will agree. I mean, you start off with a good foundation in science, so physics, chemistry, mathematics, and then you transition over to engineering. So there are specific engineering courses you'd be able to take to do that kind of stuff.
Awesome. Yeah, go ahead, James.
I would say do your best at your schoolwork. I would say learn to do math. I would also say that learning to read well and learning to write well, those are both very important. And being able to get good grades will help you to succeed in high school and will help you succeed in college. Because to be an engineer, you need to go to college to get a degree in engineering, and then you can work at a job like Julio and I work at.
And I love that you said University of New Mexico. I love that, because this is something that we're trying to push throughout this whole festival, is that, hey, students, if you want to study and work in the field of STEAM in New Mexico, you don't have to leave New Mexico. Everybody always thinks, oh, I have to go get a degree from somewhere else, and I have to go work somewhere else. I can't work here in the state. Wrong. That is so wrong. You can get your degree here in the state for an amazing career in STEAM, and you can work in STEAM. New Mexico is really on the cusp of some amazing things, and some amazing things that we've already accomplished as a state. So keep your talent here in New Mexico, please. That's my soapbox for this entire festival. We're getting some other questions coming. Let me scroll through our chat here. Axel would like to know, if you can make electricity with magnets, can you use magnets to power things?
So I don't know that you can use magnets to power something. I know that you can use the electromagnetic force that you create to produce what's called work. So essentially, you could use it to move an object, how you want to. So what's very common in cars is called a solenoid valve, right? Like, as we talked about earlier. But in vehicles, you can use that solenoid valve to physically open and close, whether it's a coolant line or something of that nature. And so you can use electromagnets to physically move an object, and say, like, close a door or do a door opener. I don't know if you've ever seen where you hit the door and it pops the doors open, not just unlocks them. Mm-hmm. But those door poppers are solenoid valves that are taking electricity, essentially converting it into an electromagnetic force and using that force to open a door. And so you can use it that way. I'd have to do a little bit more research to find if you could use electromagnets to create electricity, but I don't think it works the other way around. There's too much loss and stuff like that.
Well, I think it depends on what device you're using, because an electric motor, for example, will take electricity and use that electricity to create motion in the motor. On the other hand, a generator will take motion and use it to create electricity. But those are two different devices. One is taking motion and using it to create electricity. The other is using electricity to create motion, but magnets are involved either way.
So all this talk about magnets in cars, I think, begs a very natural question that's coming up here. Is it possible to build a hover car with magnets?
Theoretically, yes. Realistically, the best example you're going to have is realistically something like that exists, which is the bullet train in Japan. So the bullet train in Japan essentially uses electromagnetic fields, and it floats on the rails, and you can hit up to 175 miles an hour. I think it usually coasts at about 125. I'd have to double check on those figures, but I know that it can break 200 without people in it. But so there are ways to make vehicles that do that. Yes, it's just, could we make a consumer vehicle like a car do that? I don't have the answer to that one.
I think it's possible, but it would be pretty difficult. The train works because the track is always underneath the train, and the track has magnets and semiconductors and all sorts of things that let the train stay on the track. But once the train went off the track, it wouldn't be good. It wouldn't work. So I think it would be hard to make a car that levitates, but it would be possible.
Yeah. So that is cool, though, that we do already have like a hovercraft kind of vehicle, right? This train out in Japan. That's pretty awesome. I'm sorry, I'm going to butcher this name. Yuda or Judah, I'm not sure. Judah is asking, how many times would you need to wrap the wire around the solenoid to pick up 100 paper clips?
So, Judah, I think that's a really, really good question. What I'm going to pose to you is, what if you did that experiment? So now you have a question that you want to find out. So what if you did that experiment? What if you tried, so we did one that was about 1,000 wraps. What if you tried 2? We picked up, James, I can't remember, was it 35 paper clips?
About 30, I think.
It was about 30, and we had 1,000 wraps. So, if you had 2,000, would you pick up 60 or would you pick up 80? So that's where that's part of the experimenting and using the scientific method to say, okay, what do we do? So maybe that's something for you to try out at home, or over Zoom with your class.
Yeah, it's a great question. And of course, these videos are being recorded. So Yuda, if you want to access this video after we're done with this and see how they did it and try this out at home, of course, with your parents' permission, you can absolutely please do that. That's awesome. Rodrigo would like to know, can you make robots?
Oh, yes, absolutely. You can make robots. And robots are so cool. And so robots are about using electricity, using magnets, using computer programming as well, and using computers. And when you have a knowledge of those sorts of things, you can make all kinds of robots that drive like cars, that walk. And so, yes, you can make robots, absolutely.
Very cool. Do you guys get to make robots at work?
Not at work, but
No.
at home. I have a 4-year-old, and so we'll build like little spider robots and things of that nature. So he gets to play with them, or little car, like remote control cars, like real simple ones, so he can play with them.
That's awesome. Well, and on that question, Nadine wants to know, how much practice does it take to be a robot builder?
Mhm.
Probably a lot of practice, I imagine. You don't
Yeah,
want
it takes a little bit of time. So you need, at minimum, you need the kind of the education portion of it, right? So you need to go to college, you need to do the math, the science, and then do all the engineering classes, and then you need to start practicing from there. But you can certainly, I'm sure there are various tutorials online that show you how to make a real simple robot, and you can do that from home just by experimenting and following those directions. And there are, I'm sure your parents could find a couple links here and there for something you could do like that, so you could make your own robot at home.
to. And I think on Amazon too, they sell little robot kits, so you could probably take a look at that and do something fun from home during this lockdown. So Allison would like to know, is your job fun?
I would say my job is fun. Engineering is all about solving problems. And so every day is different. There's always some question, some kind of thing that we're having to figure out if we can design something, if we can build something that will solve a problem. And I think that that's one of the funnest things about being an engineer is solving problems every day, and it is fun.
Awesome. Julio, how about you?
Oh, I 100% agree.
Yeah.
Problem solving, lots of fun. But the coolest part is you get to play with all these cool tools, and you get to build and break all sorts of things. And yes, I said break because we break a lot of stuff, because that's how we know if it's made how we need it to be made. So we break a lot of things. So if you enjoy breaking things and figuring out why they broke, that's what mechanical engineers do. It's fantastic.
I think we had a lot of ears just perk up at that too on the live stream. So this one's a three-part, asked by three students, all from one class. So they'd like to know, this is from Sophia, Milton, and Alejandra. They would all like to know, how hard is it to make machines and how long does it take?
I would say it probably depends on the machine. Some machines are very simple. Maybe they would take a day to make, but if you were building something complicated, like a refrigerator or a car or something, then that could be very complicated. Some parts take years to build, and it takes lots and lots of planning and engineering, and but some things take very small time. Some things you can build in one day.
Awesome. Allison M would like to know, how do you find magnets in the earth?
So
It's a good one. It's a good one, Allison. You stumped him.
So typically we do them when we so I know that naturally occurring magnets usually are found in sand deposits in different parts of the world. So it's typically when people are excavating, either excavating, so like in a quarry, so they're pulling out rocks and to use for whatever they're going to use it there. And so that's typically how you end up finding them, is when we're excavating. So it's when they're digging for something, and you typically have to go a little deep to find the decently strong ones. I believe the strongest ones are called magnite, if I'm not mistaken. And that one's it's black and it's really, really shiny. But those are kind of hard to find. But typically, yeah, it's when we're looking for, when we're in quarries looking for something or excavating for other materials, you'll usually find that in there.
That's pretty awesome. That's very cool. Honestly, my mind has been blown this whole time knowing that magnets are mined, so I'm still processing that fact. So let's see here. So Adrian would like to know, can you make a bubble of electricity?
Well, Kind of. So whenever you have something that has an electric charge on it, there's something called an electric field that surrounds that electric charge. And so if you've ever had that experience of walking through your house, maybe you touch the light switch and it's a shock, it's a little shock, that's an electric charge that's built up on your body. And in that case, there isn't an invisible electric field that surrounds you. So it's kind of like a bubble, I guess, but it's called an electric field, and electricity does produce that.
Okay. Awesome. Yeah, that's great. And so building on this, on the magnets here, so why is it that magnets can destroy or disrupt like a credit card or sometimes a phone? You know, if we get a magnet too close to those devices, sometimes you notice some things going on there. Great question.
So I know with the credit cards, it's because the back of the credit card is a magnetic strip itself, and so when you swipe it across, it has a bunch of ones and zeros embedded in there, and so when you swipe it, the machine reads that. But that is somewhat magnetic. So if you had a strong enough magnet, you could come in and actually kind of disrupt how that data is stored on there, which would mean that you destroyed the credit card. Wouldn't be usable as a credit card. You couldn't swipe it anymore. Now, when you get to phones and electronic devices, I know it was more prevalent earlier in the technology days. Like you weren't allowed to put like a magnet on top of a television because you could destroy the television, but that's because I'm ancient, and those TVs don't really exist that much anymore. But nowadays, most of our electronic devices have shielding around the critical components, and that's why you shouldn't be able to do that. Although if you do have a strong enough magnet, when you pass it through like a hard drive, you pass a hard drive past a really, really strong magnet, it will wipe it. And that's something to do with the same thing of the disks inside the hard drive are storing everything magnetically. And so when you run it through a really strong magnet, it destroys that data. It destroys what's being stored on there.
I see. Okay. Awesome. Thank you for that. Viviana would like to know what type of tools do you use at work?
I think for me, that depends on the day. Sometimes I use drills to drill holes in things. Sometimes hammers, screwdrivers, but some of the coolest tools are a little more complicated. One of the tools that we use is 3D printing, which means that if you can design a part in a computer program, there's a machine that will make it for you out of plastic or another material. So that's an example of some of the tools we use.
Yeah, I agree. We use calipers to measure, rulers, calipers to measure things, screwdrivers, like James was saying, drills, hammers, and then there's specialty equipment. There's these, I had a previous job where we were dropping something at these really, really high rates. So it was dropping from like a story high, so like from the ceiling high, and it was slamming it down on a piece of aluminum. We were trying to see what the part that we designed did, if it was going to survive. We have vibration machines that shake everything. So it just depends on the day and depends on what you're working on. But yeah, we use a lot of different tools. But yeah, one of the coolest ones I think James was saying is 3D printing. And if you guys haven't seen it, it's really, really cool stuff.
Yeah, that technology really is amazing for 3D printing. I mean, you can almost make anything. It's in 3 dimensions. It's pretty fantastic. And we're getting a couple more questions coming in here. Milton would like to know, I think this question is, can you power robots with solar panels?
Yeah, you could do that. So solar panels can produce electricity they take energy from the sun and convert it into electricity. And so, yeah, you can use that electricity to power a robot, definitely.
Awesome. It's the students like your background. They want to know, what is it? Is it a missile?
Oh no, it's an X-wing from Star Wars.
That's awesome. That's awesome. There you go. There you have it. Yeah, it's definitely hitting the chat, your background. So can you make, this is from George, can you make Teslas and cars?
Like me personally?
Yeah, that's what the question says. I would imagine, maybe we'll loop it into magnets. We can say, can you make Teslas and cars with magnets?
Oh yeah, 100%. So Teslas are fully electric vehicles, and that means that they don't have a regular engine like we do in our normal cars, right? Like your parents have in your normal cars. So with a Tesla, instead of having an internal combustion engine which uses gas and it mixes it with air, and then that makes power so that you can move, the Tesla doesn't do that. The Tesla uses batteries that you recharge, and then those batteries actually power these giant electric motors that essentially use magnets and electricity to produce power and torque and get you moving. So yeah, you could definitely make Teslas and cars with magnets. Matter of fact, you kind of have to make them with magnets.
Another thing I would add to that is whenever you see something in society, like maybe you see a car driving down the road, maybe you see an appliance in your kitchen, like a toaster, there are engineers who work on those things and design those things. So at Tesla, at the company, there are lots of mechanical engineers, and their job is to create Tesla cars. And so that's what they do for a living. And so if you become an engineer, then you might be able to be an engineer designing and building Tesla cars. It's pretty cool.
Yeah, that is very cool. And I'm being told that those questions are from Rodrigo and Alejandra. So I misread the question asker there. So apologies, students. Do you know how to make, do you know how they make, we're getting comments in, and so the one that I'm reading gets bounced up. So do you know how they make video game controllers?
Yeah, so actually I do know this one because I play a lot of games. And so basically they start off with what they want. So let's say the Xbox controller, right, or the PlayStation 4 controller. They wanted to make sure it had rumble. They wanted to make sure it had the sticks. They wanted to make sure it had the buttons. So once they knew how many buttons that they needed for the system, and once they knew the kind of sticks they were going to use in the electronics, then you go and design the outsides of the case, and that kind of dictates whether the buttons, like on PlayStation, are right on your thumb, the thumbsticks, or on Xbox where the thumbsticks are kind of askew, right? So Xbox decided, their engineers decided that, oh, this is a better place for the thumbsticks to be, is across from each other diagonally. Whereas PlayStation decided, no, ours are going to be kind of in the center. So once they've done all those, they've made the design, they do the prototypes, which means they just take all those parts together, they put them together, and then they test them and see how good they are, how good they feel. Once they've done that, then they send it out for mass production. They'll do injection molding and all these kinds of things, which are more production rated portions of the engineering aspect. And then they create the controller that you have at home. And then after that, it's like, okay, people like the different colors or things of that nature. But the initial one, if you notice, all those other controllers, even the ones that are all different colors, they're all the same shape because that was what they decided was the best shape for hands to grab, that they felt was great. And all that is engineering. All that is figuring out what's going to work the best for your customer. So PlayStation decided that the thumbsticks in the middle was the best for the customer. Xbox decided that the thumbsticks diagonally from each other were the best thing for the customer, which is you, which is me. And so, and then we play on those, and that's how they get made. But yeah.
That's really awesome. And that question came from Santiago. I forgot to read that there in the beginning. But yeah, that's amazing. And it's things that I think a lot of folks, including myself, take for granted, right? is that everything from the way the controller, as Julio was saying, angled to how it fits inside your hand is all carefully thought about, crafted. You know, I'm obviously on the computer using a mouse, right? Everything like that is all designed very intentionally from the beginning. So that's a great question there, Santiago. Allison would like to know, so do you use a lot? Do you prefer, if you were to choose between a lot of magnets to do a job or one large magnet, what you would choose there?
So I think I'm gonna go with that depends on the job, because you might have, the requirement might be, oh, we have this giant space and it doesn't matter how big the magnet is, we just need it to do the work. Or you might be in a situation where we're very limited on size. You know, we can't make the magnet 5 feet tall, but we can make it 4 feet long, and we can make it, you know, more cylindrical. So now you can have all your magnets in a row that way. So it depends on and that's part of the engineering, the science aspect, trying to figure out what you need to do to get the job done, and to get the design complete. And so yeah, I mean, what would I prefer? I'd prefer the huge magnet because it looks cooler, personally. But but you know, it just comes down to what's needed, right? What's needed is, you know, sometimes it's not up to you, it's up to whoever's saying it needs to go here, or what the job requirement is.
Yeah, and for example, if you're using magnets, like say to place papers up on your fridge or maybe on your whiteboard, then you probably want a lot of little magnets, right? Because you want one magnet to place this paper, one magnet to place this paper, etc. But if you go to a junkyard and you have those big cranes that they have big electromagnets that actually come in and pick up tons and tons of metal. They'll pick it up off the trucks and drop it down to another area. In that case, it might be helpful to have a really big electromagnet to help with picking up all that metal.
Awesome. Viviana wants to know, do you store your magnets in a particular place?
I like to put mine on the refrigerator, but that's just me.
No, not really for me. I think I have a bunch of magnets in a cardboard box in my closet, but I didn't really think about it. I just put them there.
It's awesome. Yair wants to know, how does a jacket or a hoodie? Oh, this is a great question. Okay, so you know when you're putting a jacket or a hoodie on and it makes electricity when you take it off, could you explain that? You get a little shock sometimes when you take a jacket or a hoodie off.
I think that's a difficult one to explain. I think basically what it comes down to is there are these very, very small particles called electrons. And sometimes an object might be filled with a lot of electrons on it, and it has a large electric charge. Sometimes an object does not have a lot of electrons. But if you have one object that has a positive charge on it and one object that has a negative charge on it, those electrons are going to flow from negative to positive. And so when you say you take your hoodie off, there's a lot of crackling. Maybe you go to a metal surface and you touch it and you get a shock. Those are electrons flowing from your body to whatever you touched, or from whatever you touched to your body, just because of the difference in electric charge.
And this kind of, I think, fits into what you were talking about earlier when you touch like a knob sometimes and you feel that shock as well, right? I think you were talking about the electromagnetic field. And so this kind of factors into that same thing, right? So it's neat when you feel that charge. You know, I think about it actually now that it's getting colder. Sometimes you get under a blanket and you feel the same thing, right? Or you'll even see your hairs kind of stand up on your arm. This is all this kind of thing that we're talking about here, is that it's all a part of this electromagnetic field and the transfer of these electrons. So that's a great question there, Yair. And then wanted to pass this along. This is a great note from the Ramirez Thomas elementary class. They're up in Santa Fe. They said thank you to both James and Julio. They were all really inspired by your presentation. So big shout out from them to you both. So
thank you. Thank you for watching us.
Thank you.
Awesome. I'm not seeing any other questions coming in right now, but not to fear, students. If you still have questions or you want to see this presentation again, don't forget you can access this recording by visiting our website, discoveryfestnm.org. And then you go into there, there's a calendar. You can find today and find the time that we started this at 2 o'clock. It'll have this presentation there on YouTube for you to watch whenever you'd like. And then, of course, you can try the experiment that Julio and James did on the stream. That's all I'm seeing, you two. Thank you so much for coming on today and being here as a part of our live stream.
Thanks so much for having
thank you for having us.
All righty, you guys take care. Stay safe.
Okay, sounds good. Bye-bye.
All righty, bye. Take care. I also want to give a quick shout out. Again, thank you to Julio and James for being on the program today. I want to give a quick shout out as we're wrapping up here to our wonderful and amazing sponsors who have supported this event during this crazy pandemic that we all find ourselves in. Again, what you saw today and what you're seeing for this festival would not be possible without these sponsors. So thank you so much, Honeywell, again, for coming on today and for being our presenting sponsor for Discovery Festival. We couldn't do it without you. To Fidelity Investments, Aztec Machine and Repair, Air Force Research Laboratories, and then the other 4 sponsors there you see at the bottom left of your screen. And thanks to all of you for tuning in. We're getting a lot of awesome comments from the classes. Thanks for participating. Thanks for being here. Don't forget tomorrow, if you're around, I know it's not a school day, but if you're around tomorrow, you can check our schedule online again. But we're doing a really neat live robotics demonstration. We have this really great R4 Creative Robotics Lab. They're making robots. We got a lot of great questions about robots. So tune in tomorrow and you can see some robots being built and see some robots in action and can ask questions about robots to people who are building them there on the live stream. Should be a blast. So please tune in for that if you're around tomorrow. And you can check that time on our website again, and we'll post it in the YouTube chat, discoveryfestnm.org. Okay. Find all the information there. Otherwise, happy Friday the 13th. Stay healthy. Stay safe, and we will see you tomorrow. Bye-bye, everybody.